Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video we are going to learn about intersection of two sets. This is one of the operations of sets. What do you mean by intersection? This word, we have heard about this word even in geometry. Intersection of two line segments, intersection of two angles, intersection of two rays, so on. So what do you mean by this intersection? If at all I consider two sets A and B is the set of vowels A, E, I, O, U, then the set intersection of A and B is nothing but X such that X belongs to A and X belongs to B. In the earlier video for union we have seen it is going to be X such that X belongs to A or X belongs to B. Here it is X belongs to A and X belongs to B. The difference is here it should belong to both the sets, right? So what are all the elements which belong to A as well as B? Let us identify the elements which belong to A as well as B. The element A belongs to both A and B. The element E belongs to both A and B. Isn't it? Are there any more elements? No. So it's going to be A comma E. So the set A intersection B consists of the elements A and E. So it's going to be, its cardinal number is 2 here. The cardinal number of A is 6 and the cardinal number of B is 5. Cardinal number of A intersection B is 2 here. Right. Now this is the definition of intersection of two sets. What are the properties of intersection of two sets? Can we find out the intersection of two sets if the sets are given in set builder form? Let us find out. A is a set such X such that X is a multiple of 3 and X belongs to natural numbers. B is X such that X is an even number and X belongs to N. Okay. This is an example where A and B are given in set builder form and we are going to find out intersection of these two sets. To find out the intersection of the two sets, we need to know what are the elements in common to both the sets. For that, we need to find out the set in roster form or represent it in roster form. First of all, we will write down all the elements of A. Let us understand the definition here or the condition here. X such that X is a multiple of 3 and X belongs to N. So what are all the multiples of 3? And we need to remember that X belongs to natural numbers. So 0 is ruled out. All the multiples of 3, 6, 9, 12, 15, 18, so on. It is going to be an infinite set. Okay, fine. A is written and now B. B is X such that X is an even number and X belongs to natural numbers. Or in the other ways, we want all the even natural numbers. So 2, 4, 6, 8, 10, 12, so on. Okay, we have represented both A and B in roster form. I want to find out the intersection of A and B. Intersection, as we have already learned, is going to be the set of all the elements which are in common to both A and B. What are the elements which are in common? 6 is common, 12 is common, 18 is going to be common because 18 is an even number. So we can write it as 6, 12, 18, so on. Observe, intersection is also an infinite set. So we are given an example where given the sets are in set builder form. We have first represented those sets in roster form and then found the intersection. The concept of intersection is the elements of the intersection are the elements which are in common to both A and B. It should be every element. It's 6 is in A, 6 is in B as well. 12 is in A, 12 is in B as well. So the common elements, we will highlight the common elements and we will make a set of it. That is the procedure to find out the intersection of two or more sets. Now, as we have observed in the union of sets, does intersection also follow the commutative law, associative law and so on? Let us observe. Before that, in this example, A intersection B is 6, 12, 18, so on. Is this a subset of the set A? Let us observe. Every element of A intersection B is in A. Therefore, A intersection B is a subset of A. Similarly, is every element of A intersection B also in B? 6 is in B, 12 is in B, 18 is in B, so on, because all these are even numbers. So A intersection B is a subset of B as well. In the case of union, we observe that A is a subset of A union B, B is a subset of A union B. If we understand these two comparatively, it becomes very easy for us. A and B are both subsets of A union B. Here A intersection B is a subset of both A and B. So we can comparatively understand the concept, right. Now moving on to commutative law, associative law and so on. Let us quote an example here and then follow the properties regarding that example. If we consider I have chosen the first 5 even numbers or first 5 multiples of 2, and then B is 1, 3, 5, 7, 10. Okay, then what is A intersection B? A intersection B is 2, 4, 6, 8, 10 intersection 1, 3, 5, 7, 10. We need to choose the element which is common to both. Here only 10 is common to both. So A intersection B is equal to 10. Now what is B intersection A then? B intersection A is 1, 3, 5, 7, 10 intersection 2, 4, 6, 8, 10 again. Now the element which is in common to both B and A is 10 again. So B intersection A is also 10. So from this example we can note down that A intersection B is equal to B intersection A. So it is commutative. The intersection of two sets is commutative. How about associative? How about associative? For checking associative property, we need 3 sets. So we have chosen A, B and C. We have to prove or check if A intersection B intersection C is equal to A intersection B intersection C. We have to check this. This is associative property of intersection of sets. Let us consider LHS. A intersection B intersection C is going to be 2, 4, 6, 8, 10 intersection. B intersection C is 4, 5, 6, 7, 8 intersection 7, 8, 9, 10, 11. So we are going to find the intersection of these two sets first of all. It is going to be, what are the elements which are in common to these two? 4, no. 5, no. Only 7 is common. Yeah, 8 is also common. So the intersection of these two sets is going to be 7, 8. And A is as it is 2, 4, 6, 8, 10. So B intersection C is 7, 8. Now what is common to A as well as B intersection C? 2, 4, 6, 8. 8 is common. So it's going to be 8 over here. So A intersection B intersection C is 8. What about the right hand side? We need to find out A intersection B first of all. 2, 4, 6, 8, 10 intersection 4, 5, 6, 7, 8. We are going to group this and then find the intersection with 7, 8, 9, 10, 11. Let us observe. The elements which are in common to A and B are 4, 8, isn't it? 6 also. So we have 4, 6, 8, 4, 6, 8. Right. So we are going to have 4, 6, 8 as the elements of A intersection B, and then 7, 8, 9, 10, 11. So what are the elements which are in common to A intersection B and C? 4, 6, 8. 8 is in common. Therefore, it's going to be 8. So A intersection B intersection C is equal to A intersection B intersection C. So we have observed that intersection is commutative and also follows associative law. Now, if A is 2, 4, 6, 8, 10, then what is going to be A intersection empty set? This is empty set or null set. What is it going to be? 2, 4, 6, 8, 10 intersection null set. So this is what I want. A intersection empty set. What is the solution going to be? What is the set of intersection of A and empty set going to be? Yes, the elements of A intersection empty set are, these are the elements of A. There are no elements in B. So what can be the common elements? Empty set itself. So A intersection empty set is empty set itself. In the case of union, we have found out that A union empty set is A itself. If we learn comparatively, as I have said earlier, it becomes very simple. At the end of the session, we are going to learn all the properties once again as a comparative study. So these are the properties of intersection. And we have also seen that A intersection B is a subset of A and A intersection B is a subset of B. Okay. Now, if A is contained in B, then what is A intersection B going to be? If A is contained in B, then what is A intersection going to be? Let us consider a simple example. A is 2, 4. B is 1, 2, 3, 4, 5. Okay. Here A is clearly contained in B. A is a subset of B. Then what is A intersection B going to be? All the elements which are in common to A and B. 2 and 4. So A intersection B is 2, 4, which is nothing but A, isn't it? If A is contained in B, then A intersection B is equal to A. If B is contained in A intersection B is going to be B itself, right? Let's quickly recap all the properties of union and intersection as a comparative study. This will help us to understand the concept betterly. We will learn about union and intersection. A union B is equal to X such that X belongs to A or X belongs to B. A intersection B is equal to X such that X belongs to A and X belongs to B. This is the basic difference in the definition itself. Then A union B is equal to B union A. Similarly, A intersection B is equal to B intersection A. A union B union C is equal to A union B union C. So both intersection and union follow commutative property as well as associative property. What is A union empty set? A itself. What about A intersection empty set? Empty set itself. A is a subset of A union B as well as B is a subset of A union B. Coming to intersection, the intersection set is a subset of both the sets A and B. We have seen ample number of examples here. If A is contained in B, then A union B is equal to B itself. If A is contained in B, then A intersection B is A itself. So these are the properties of union and intersection as a comparative study. This is a basic definition of intersection and union. Commutative property, associative property, union with empty set, intersection with empty set. A and B both are subsets of A union B. A intersection B is a subset of both A and B. If A is contained in B, then A union B is equal to B, because here A is inside B or A is contained in B. So if I explain this using an example, A is contained in B. This is a Venn diagram. A is inside B. So union is going to be B, entire elements of A as well as B. So it's going to be B here. Similarly, if A is contained in B, intersection is the elements which are common to both A and B. So A is going to be intersection of A and B. right? So we have learnt about intersection in particular, what are the definition of intersection, what are the properties of intersection, and at the end of the session we have learnt about all the properties of union and intersection as a comparative study, so that the properties become very simple for you. This is the end of the class, and we will meet in the next video. Thank you.